Hey, good afternoon all. So we are going through the learning rules of neural networks, and we'll see one more type of learning rule in neural networks, that is Boltzmann learning rule. So your learning rule is a stochastic learning algorithm which is derived from the ideas rooted from statistical machines. So Boltzmann learning is based on the one Boltzmann machine which is designed as per the few rules. So that's why it is a learning process based on the stochastic learning methods, and a neural network designed based on this rule is called the Boltzmann machine. So Boltzmann machine gives the or it performs the neural network operations based on these rules. So what are those rules? We'll discuss here. In a Boltzmann machine, the neuron constitutes a recurrent structure and they operate in a binary manner. A recurrent structure means here it has some feedback loops. Repeatedly, it has some feedback loops, and these things will be operated in a binary manner in the Boltzmann machine. So here on state is denoted by the +1 and off state is denoted by the -1. So on state is means if neuron is on means then it is +1. If neuron is off means it is denoted by -1. So if we see how this machine is characterized, means this is characterized based on this energy function. So the machine is characterized by an energy function which is equal to E equal to -1/2 summation j summation k wkj xk into xj. So where j is not equal to k. So here where xj is equal to the state of the neuron j, all j and k will vary from j is equal to 1 to n and k is equal to 1 to m, and wkj is the synoptic weight from j to k, which is nothing but the connection link weight, which is from j to k. J may be 1 to n, k may be 1 to m. So those are the you will get each input vector or input neuron is connected to all the output neurons, right? So based on that, multiple connection link will be there. Based on that, you will get the connection weights as wkj, wk1, wk2. If k is also equal to 1, w11, w12, w13, and so on, w1m. Again, w21, w22, w3, w23, and so on, w2m. Likewise. And here j is not equal to k shows that none of the neurons has self-feedback. So there are no self-feedback. That's why j is not equal to k in this energy function. What is the probability function to get that state of the neurons means here this machine is operated by choosing a neuron at a random. It means randomly the neurons will be selected. Let's consider that neuron k at some step of learning process. As learning process is continuing, the machine will select the neurons randomly. In that process, if the machine selects the neuron k, then flipping the state from xk to x minus k. That means flipping the state from xk to x minus k means from on state to off state or off state to on state. flipping its state from on to off to on. At some temperature T with some probability means, what is that probability means? See, a temperature also it includes in the Boltzmann's machine. So what is the probability means? The probability function given as by the Boltzmann, P of probability of xk to x minus k, to change or to flip that state from one state to other state. That xk to x minus k indicates that flipping the state. Probability of xk to x minus k is equal to 1 by 1 plus exponential of minus del ek by t. So it is a function of temperature as well as changing that error energy. So where del ek is the energy change, already we have seen that energy function, that's why we have considered there 1 by 2 to differentiate that error and to minimize that error. If you differentiate that error 1 by 2 and 2 and 2 will be get cancelled and that need to be minimized. So that's why that energy function is selected with 1 by 2. So del ek is the energy change and T is the pseudo temperature. If this value is applied repeatedly, then the machine will reach the thermal equilibrium. So here temperature also plays a role. How the temperature will plays a role means all the input as well as the output neurons will be exposed to the environment also, except the hidden layers. So that environment will plays a role to flip the states of the exposed neurons. That is nothing but either input or output neurons. So what are the types of neurons and operations in this Boltzmann's learning rule? The neurons are partitioned into two functional groups here. So one is visible neurons, second one is hidden neurons. In the visible neurons, they provide the interface between the network and the environment. So here visible neurons, we can say that visible neurons are the input neurons as well as the output neurons. But there are hidden neurons also. Those hidden neurons are not exposed to the environment. Only visible neurons are the input and output neurons. Those have interface with the environment. Those neurons, input as well as output neurons, are interfacing with the environment also. That's why those are called the visible neurons. And second one is hidden neurons. They always operate freely. It doesn't has any effect with respect to the temperature. That's why these always operate freely. Apart from these types of neurons, there are two modes of operations. One is clamped condition operation, another one is free running condition. So in the clamped condition operation, in which the visible neurons are all clamped onto specific states determined by the environment. That means in the clamped condition, it is correlated with that visible neurons. So this visible neurons state will be decided by the environment. Based on the environment, the visible neurons will turn on or turn off. That state will be decided by the environment. That operation is called the clamped condition operation. The second operation is free running condition, in which all the neurons are allowed to operate freely, like hidden neurons. Hidden neurons doesn't depend on the environment, so that operation is called the free running condition operation. Again, like in other learning methods, how that weights are updated here in this Boltzmann learning rule. So you have to update the weight. Here two parameters are considered, that is rho kj plus is the correlation between the states of j and k in its clamped condition. There are two modes of operation, right? One is clamped condition operation and the one is free running condition. So in the clamped condition means which are exposed to the new environment, those operating states of the neurons will be decided by the environment. That's why that is clamped condition. And the free running condition is nothing but with respect to the hidden layers, which are operated freely. So the correlation between the J and K in its clamped condition is denoted by this rho Kj plus, and rho Kj minus is the correlation between the states of J and K in its free running condition. So free running condition is denoted with minus and the clamped condition is denoted with plus, where K and J are the neurons. So from jth neuron to kth neuron, the rho kj is nothing but the weight of the connection link from j to k. It is denoted with plus if that weight is in clamped condition. Rho kj minus is nothing but again the connection link weight, the same connection link between the j and k neurons, but it is in free running condition. That is, if it is free running condition means that weight is denoted with minus, rho kj minus. Instead of w here I have considered rho kj plus, rho kj minus. Plus is denoted with clamped condition, minus is denoted with free running condition. But the connection link is same. For example, k is equal to 1, j is equal to 2 means rho 1 2, which is the connection link from second input neuron to first output neuron, 2 to 1, which is in clamped condition plus. It is denoted with plus. Rho 2 1 minus means, sorry, rho 1 2 minus means rho 1 2 plus, and here rho 1 2 minus. Rho 1 2 minus means again from second neuron to first neuron, the connection link weight in free running condition, rho 1 2 minus. So both correlations are averaged in its thermal equilibrium. When it gets the thermal equilibrium, there both the correlations are averaged, and as per according to the Boltzmann's learning rule, the change in weight, here we need to update that weight, right? To update that weight we need what is the change in weight. So if you know the change in weight, that change in weight will be added with the previous weight to get that updation. So here the change in weight del wkj is equal to neta into rho kj plus minus rho kj minus. As per the Boltzmann's learning rule, the change in weight is derived as neta into rho kj plus minus rho kj minus, which is nothing but the difference between the weights of the same connection link when it is operated in the clamped condition and free running condition, rho kj plus minus rho kj minus. So where neta is the learning rate parameter, and rho kj plus and rho kj minus are the values which will vary from -1 to +1. So here we have taken those limits of the connection link weights as per this Boltzmann's learning rule. Rho kj plus and rho kj minus are the values which are varying from -1 to +1. So it is varying between these two values. You may get some values, those need to be averaged, and it will be used in the calculations of the change in weight del wkj. So likewise, as this Boltzmann machine also has a recurrent networks, that is nothing but feedback loops. So the change in weight will be updated, the weights will be updated by using this form. So here Boltzmann machine will decide which neuron need to fire. Randomly it will pick up and it will perform all these operations. And here one more extra parameter is included, that is temperature. The pseudo temperature is also included. So as per the temperature, effect will be there on the only visible neurons. It is nothing but input neurons as well as the output neurons. And the temperature effect will not be there on the hidden neurons, which will be operated freely. It is all about the Boltzmann's learning rule. Thank you all.